Hello, I'm Nela. I came from Croatia, Split, and I'm physics high school teacher. And today I will speak about enhancing student engagement in high school by designing research in high energy physics.
Creating a culture of excellence and working with talented students is an important role of teaching in high schools, especially in natural science, such as physics. By involvement in scientific research activities in all areas of physics, talented students can achieve various knowledge, skills, and competencies, especially when analyzing processes in high energy physics because the work is very dependent to collaboration with researchers in universities and excellent technological attractive laboratories.
Encouraging excellence and working with talented students should be an integral part in teaching physics at pre-university education levels. In regular high school curricula, topics from modern physics are mostly at the level of facts or implementation of concepts and principles to unrealistic systems. Thus, for talented students, we have decided to teach and train them for a potential experiment for the International Beamline for Schools at CERN, which is intended for high school students from 16 to 19 years old. By working with talented students, it is necessary to develop a scientific research approach to solve any problems in various subject areas. Modern physics topics, such as high energy physics, are particularly attractive to a large number of high school students, but only talented students can respond to various challenges that can appear within international competition in high energy physics. In addition to core subject knowledge and skills, attractive international competitions create new platforms for achievement and additional cross-sectional competencies. Designing a science research project in high schools through extracurricular activities with talented students includes different actions: presentation of motivation, objectives of the research, setting the hypothesis, and elaborating its theoretical basics. For a relevant science project, it is useful to find answers to the following questions: what topics could be researched and why? Who are the main users of the results and the target groups to whom the results should be presented? What are the potential benefits of the results and how can they be exploited? What is the starting hypothesis? What is already known in relation to the hypothesis and what is unknown? What has been analyzed so far? What theoretical basis is taken for the planned research? How to choose relevant literature? Does the selected literature provide all the necessary theoretical basis for research? And does the selected literature include previous similar and related research activities and results? For all involved students, it was quite challenging task to set a relevant hypothesis, which should be attractive, feasible, and understandable for them. The JIBU simulation package on high energy reactions has been a very useful tool in order to understand better the reaction systems. They analyze the cross section as a function of beam energies of electrons to nuclei in the target. Very interesting particles that were produced in simulation at assumed beam energies of electrons were pions. They also read relevant literature and final. After a series of lectures, discussions, and simulations, the students accepted the following hypothesis. The ratio of the number of positive and negative pions formed in the reactions of electrons to nuclei in targets depends on the quark structure, which should be reflected in a cross-section of scattered electrons on targets. By preparing this research project, the involved students have achieved the following subject knowledge and skills, and wider cross-sectional competencies. Describe basic characteristics of elementary particles, describe applies concept of special theory relativity, explain the trajectory of charged particles in a magnetic field, apply concept of wave nature of the particles, laws of energy and momentum conservation, install and use the computer simulation package, adapt and apply information technologies, preparation of presentation and videos, responsibly perform accepted tasks in the project, successfully collaborate and communicate with other members during the teamwork, successfully self-organize and participate in the organization of teamwork, successfully communicate with scientists at universities and research institutes in foreign languages. The science project's activities, as presented in this paper, are very motivating, enabling progress for both to students and to their teachers. Such activities make also possible to connect students from other schools and countries in a joint team, as well as to connecting talented students in different fields, physics and other natural science, mathematics, information technologies, arts, photography, and others. The science project activities enable talented high school students to go through all steps of a modern and authentic research work very early and to become partially involved in it, while depending the cooperation of high school with universities and world-famous research institutes, which is recommended in many national curricula. Students are satisfied with this approach because they solve problems from real research space. Teaching mentors are also satisfied with this approach, and we expect greater involvement of researchers in the future as well. Approach can be the basis for creating a new curricula for talented students. Thank you for your attention.